I've had it for a few years. I'm not sure how long I get on the charge anymore. So, let's get normal. We are going to engage in some radical normality. So, normalization. Partie 2. So, this lecture consists mostly in a reinforcement of concepts from last week, but there is a bit at the end where we talk about the transactional nature of modern society. No, I mean databases. But, all in due course. Behold, unnormalized data. Blech. Although towards the end we're going to see why some people actually like their data unnormalized. But, how can we tell that this data is unnormalized? Repetition of what?
You got lots of white space in the STU no.
Oh, yeah.
That's right. Remember, when you see white space like this, it means that this is implicitly here and here as well. So we have a lot of reputation. We have a lot of repetition in the student number column. This data is unnormalized. So, what do we think would put the table into first normal form? So here's the question. What do you do to achieve the first normal form? Does anybody remember from last week?
You do attack on columns?
You do an attack on the columns. That's right. Remember that previously, the example that we started off with, if we put this data in that example, we would have fee 1, paid 1, amount 1, fee 2, paid 2, amount 2, fee 3, paid 3, amount 3, right? We would have redundant columns. In this particular example, and we saw one of these towards the end, it's not like the information has been clustered in this manner. It's not like, it's not with explicit columns done out, but really, like, we need to have all of the information in every row, right? What was blank space should be filled. That's number one. What's another thing that we do under first normalization? Yes? Very good. We remove calculated columns. Now, do we happen to have any calculated columns in this example?
No.
We do not. Gesundheit. There are no calculated values in this example, so we don't have to worry about it. So, populate student number. Boom! Welcome to the first normal form. We have attacked the columns. So, let's see here. Question. What is the key? How many people think student number? How many people think fee? How many people think paid? How many people think amount? How many people think it's something else? Nothing?
There's repetition, so there's still right?
All right. Yes?
I think maybe the key would be a combination of two things.
Yes. A combination. So remember that when we're looking for keys, we're looking for any column or combination of columns that produce a unique value for every record, right? So, which two columns could we combine to form a composite key in this case? Student number and fee. We could do student number and fee. That's this one. Yep.
And now just kind of bound the fee as well. All co-ops are 400, all parkings are 150, all sites are 100, but that could be left to a later.
Yes. So what we're identifying here, what you've just identified, is that the amount column is entirely dependent on the fee, right? This is a dependent attribute. It's dependent on fee. But as is always the case with dependencies, we could also consider this column to be dependent on that one, right? Now, logically speaking, we can perform that inversion. If we're looking at this data with our human brains, right, and interpreting what the table says, it is more, the way things work, that the amount should be determined from the type of service and not the service from the amount that was charged, right? Because although each of these services has a unique amount in this example, it's not inconceivable that we would have an amount, like two different types of fees that both are in the same amount. In which case, amount no longer works as the key. Right? Does that make sense?
Yeah.
Very good. Does that make sense to this half of the room? Okay, good. I figured out the reason that I favor this side of the room, right? It's because I'm right-handed. And this is my right-hand side. It's just, so sorry. I'll try to be ambidextrous. So, yes.
Michelle can do with lightsabers.
I mean, obviously the answer is more swords. So, the key for this table is a composite key, student number plus fee. Now, I don't know, I kind of don't like the term fee because it's fee sounds like it should be a number to me, but you are charged a fee. This is like a category of fee,
Fee sounds like it could be a different name for amount.
Yeah.
Like service instead or something.
Yeah, or charge,
Charge type or whatever.
charge type, yeah. Anyway, so recall the basic requirements of the first normal form. Cells must be single valued. That is, you're not permitted to have blank spaces. All values in a column must have the same domain, and each row must be unique. So, all values in a column must have the same domain. Let's discuss that one for just a moment. What do we mean by the term domain?
They share the same set of valid ranges, I guess?
Yes. So they have the same range, right? Range and domain are similar related concepts. So domain is a term that derives from, you may remember the term from, grade 11 or 12 functions in high school. The domain of a function is basically the x values that it ranges over, right? So, when we talk in computer speak, when we talk about domains, most of the time we are talking about data types, right? So, something that is a student number should not contain string data unless a string, like a string character, is part of the normal student number, right? Certainly amounts should not contain strings, they should be decimal values. If we have a column paid that is either yes or no, obviously implied a Boolean, we don't have it stated right here, next week when my paycheck comes in, right? It's either paid or it isn't. So, does that make sense? So, first, normal form anomalies. It's kind of fun because like the word anomaly normally means like paranormal anomaly in like the current culture. So I kind of prefer to think in that space. So, what sort of anomalies do we have? Well, do we remember the 3 types of anomalies? They're tied to 3 different types of SQL statements. They are CRUD operations.
Delete, insert, and update.
Delete, insert, and update. That's right. So, let's consider deletion. Does this data contain deletion anomalies? That is to say, if we delete a row, do we lose information?
If you delete the first one, if someone tries to enter a co-op fee, there's nowhere to say how much the co-op fee actually is.
That's good. That's right. So our first deletion anomaly, if we delete all instances of any one of these fee types from the table, we no longer know what the amount corresponding to that fee is. That's a deletion anomaly. Good. Do we have an update anomaly? Yes.
If you update how much one of the fees is, that you then have to go through and update every single thing.
Very good. So, there is an update anomaly because if we decide that parking, if we decide that the institution does not make enough money from parking, which I don't know how you could possibly determine that, given how much parking is, but let's say they wanted to increase revenues from parking, it is not sufficient for us to update that in one place. We must update every record containing a parking fee with the new information. This is an update anomaly. Very good. So we did delete anomaly, we did update anomaly. What's the final one? Insert anomaly. Is there an insert anomaly in this table?
Insert a student that doesn't have any paid amount. You cannot insert it just like that. You have to create something. You have to add that we paid an amount even though the student doesn't have it.
You are correct. Very good. If we wanted to add a new student, we cannot add a student to the system that hasn't been charged for something, right? Conversely, it's also true, we can't enter a new fee type without having it charged to a student, right? So we have insert anomalies on both of those sides. Very good. Make sense? Any questions? Very good. Very good. So, yes, we know that. Yes, okay. So, we proceed to the second normal form. A relation is in second normal form if all of its non-key attributes are dependent on all of the key attributes. So, if we were to normalize this table into second normal form, what would it look like? So, we want all attributes to be dependent on the keys. How do we go about doing that? So, first, we need to decide what is dependent on what, right? Amount is dependent on fee, that's right. What about paid? What's paid dependent on?
You can't have anything get paid if you don't have a student number to feed in the first place.
Right. So paid is dependent on the composite fee, but amount is only dependent on the fee, right? So what does this mean about fee and amount? They should be their own table, yes. So, there you go. Student number and fee have paid as a dependency. Fee has amount as a dependency. Please remember this notation as it's going to be on the exam. Hint, hint.
You mean the arrows?
Yeah, I mean the arrows specifically, but also the plus to indicate a composite key. Oh, everybody here is
So what's
I hear
gonna be on the
pencil
exam
scratching.
again?
Eh?
What's gonna be on the exam again?
This type of notation.
Everyone
Okay.
instantly perked up.
I know, right? There's no greater way to bring the attention back from wherever it was wandering.
Yeah,
What
maybe,
page is this?
I trust that you to look that up on your own time.
Okay.
I don't know.
Yeah.
And if I exit out of this, I'm gonna have to like forward space through all the ones I've done to get there, so.
maybe when you're going through your presentation and then everybody starts like dozing out, then you just gotta like throw the word exam in there somewhere.
See,
You need like jingly keys up there.
Yeah,
some,
exam,
like,
exam.
here's the thing though, right? Although it's a good technique, it only maintains its power by its association with the truth, right? So if I use it as a tactic to keep people's attention, it'll work the first couple of times I do it, and then it just won't after that.
That's how I know that you're a good parent, based on what you just said.
Well, thank you very much. If you threaten violence against your child, you gotta be able to back it up. So don't threaten the violence. Unless you're willing to supply it. And that might sound bad on the recording, I should qualify that. When I say be violent with a child, I don't necessarily mean striking the child in anger
Necessarily.
or in punishment. Like, there are plenty of ways to be violent with a child that don't actually constitute harming the child. Like, one of my children's favorite game is I pick them up and I just throw them on the bed. And they love it. It's like, general roughhousing, right? But like, they love it. They love being tossed into the air until they reach a certain size and, the bones start bending when you do that. And they're like, nah, it's okay. I'm gonna not get tossed on the bed, but I'll, but yeah, like, my 3-year-old who's a little on the small side and very springy, she just like, there's nothing she loves more than to be tossed onto the bed. But, by tossing a child onto the bed, you're also proving that you can, toss them down a mine shaft if you had to.
That's good.
So, yeah. Well, yeah, no, like, you're capable of violence, you're good, it's good violence, but
Not all
and the
violence.
but carries a lot of weight in that sentence.
Let me
So
see
there
the
you go.
violence.
Parenting tips, actually, it's actually like a really, really healthy thing to roughhouse with the children. Anyway, so So don't call Child Protective Services. Yes. So yeah, this notation. When you see the plus on this side of the arrow, that means that this is a composite key. Everything on this side of the arrow is the thing that is dependent, thing or things that are dependent on that composite key, right? So, and if there's no plus, it's not a composite key, it's just like what it's dependent on. Yes?
In case that you want to represent more than one column that depend on a specific column, how would you do that?
With a comma.
Okay.
Yeah. So like, you know, if I had a third column that was also dependent on phi, I would put comma, or I guess that would be a fifth column, comma, fifth column. You got a question?
That was the same.
Yes?
So what if it was a primary key that is dependent, the whole row is dependent on the primary key?
Well, see, this is an interesting thing, right? When we do this dependency analysis, each of these lines ends up being a table, right? So, if you have a non-composite key on one of these lines, it de facto becomes a primary key. So phi is the primary key in the phi amount table, right? Now, the only thing about it is that it's not a number, right? Maybe we want it to be a number because, you know, there are various reasons you might want that. Efficiency of lookup for one, right? It's kind of weird to have, like string comparison is just, you know. But, like, we're not at this point, like, worried about, like, adding more columns. This is a primary key. We can, you know, we can worry about adding, like, a numeric index for efficiency later if we want to, but yes.
So if something else was dependent on phi, you could add like a plus.
After this point is commas. Yeah. Yeah. So, yes. So, for example, if you had another column, right, and that extra column was, let's see, phi amount and,
PID.
no, like department, I guess, like which department is the fee goes to, like maybe like department, right, and like co-op goes to the co-op department, but parking and site fees both go to like groundskeeping, right, something like that. Right, so like it's dependent on this column, but it's clearly not capable of being the key itself, right? Because the data is not unique. In that case, you would have phi amount, comma, department, right? Amount, comma, department. If you had another department column that was dependent on phi. Make sense? Good, good. Any questions? Okay. Is this the first time this, I feel like this isn't the first time this notation has showed up, but there's probably a reason that we do this a couple of times. Okay. I'd really prefer one projector, you know? All right. Brown. Brown marker. Okay. Oh,
Whatever wants to draw blue on.
work? It works. All right.
Looks like black.
It does, but it's actually brown.
Well,
Yeah,
here-
it's like navy blue socks. Are they navy blue? Are they actually black? You don't know. You only know if a pair of socks is navy blue if it's next to black socks, right? Anyway, like this. Once I put a black, oh, do I have black market? I do not. We're getting off topic. So, third normal form. A relation is in third normal form if it is in second normal form and has no transitive dependencies. So, can anybody spot the transitive dependency in this table? Did we ever define transitive dependency?
I don't think so.
Yeah. So let's just skip ahead then. Oh man. Are we really being asked to like use a definition we were never given and then never given the definition after that?
I think so.
We might have to Google this one.
like, so it's gonna be like a calculation or something.
I know that this has probably been AI generated, but fine.
A non-key attribute depending on another non-key attribute.
Oh, when one attribute indirectly depends on another through an intermediate attribute. Alright, let's go back here. So, transitive dependency then. What is the key in this table? Student number. What is tuition dependent on? Right,
In this table at least.
in this table, well,
I would say like, if you have like an international student and a domestic student, they have two different tuitions for the same program, but it's not quite in this table.
it's not, yeah, let's just, and this is also, I think, probably representative of domestic tuition more so than international tuition. So, at any rate though, tuition is dependent on program, but program is not the key. Student number is key, right? So, that should be a table. That should be its own table, right? We already talked about deletion anomalies. So, taking this table, passing from the second to the third normal form, you can see we take this dependent, this which is dependent on program, tuition which is dependent on program, that becomes its own table. You see we also eliminate a redundant row by doing so. What remains of this table is student number and program, as the column which is dependent on this non-key value has been removed. Make sense? Question?
I'm just not sure I understand how this is more efficient on like the storage space or whatever it is, because if you're taking the same data and then just splitting it into two tables, I don't get quite how it's more efficient in that
Like
way.
if this was much longer, it would start saving space.
Yeah, so that's mostly an artifact of the fact that this is, a table with only 4 lines in which
Yeah.
only one is redundant. You can imagine, like, in the real, database that this institution keeps, the number of students in the comparison to the number of programs well, you know, I wanna make a joke about like things post, you know, international student crisis, you know, maybe we do have more programs than students now, but no, that's not the case at all. It's a joke. But yeah, the number of programs is like quite a bit larger than the number of students, so you do, in the end, save more space by deduplicating this guy. Does that make sense? Good. I'm just gonna check to make sure this thing's still running.
I hope so.
It is! Very good. So, normalization case study revisited. So if I had a criticism of the slides, we didn't actually follow the same table through, all the way through the normalization process, did we? We might have. So, although actually it is kind of nice to see a small example of second to third normal form, now that I'm thinking about it. So, recall pipes and things, right? Our case study from last week. We must determine our vital entities from our purchase order document. This purchase order has a line number, which is simply the count of the number of items that appear on each particular order. Sometimes this is known as a sequence number. That's going to be vital. So, let us consider the following purchase order. So, let's start writing down entities. Like actually writing them down this time. So, what do we have? What entities exist here?
Vendors.
Sorry?
Vendors.
Sorry, what?
V-A-N-D.
Vendor, oh yes, vendor, yes. So, vendor? What else?
Item ID.
What'd you say? Vendor ID. Does vendor ID occur here?
Top left.
Ah, yes, there you go. Vendor ID. So I guess this would be vendor name, vendor ID,
Vendor address.
vendor address. We'll just call it address, we won't worry about lines of the address, alright. Next,
Postal code, unless that's in the address.
that's purchase order number. If you're talking about PO,
Oh no, they're like, well, the address has a, I don't know if you
Oh,
would separate that.
let's just say we've
Yeah.
done that one.
Yeah.
So we've done that, we've done that. We've done
Vendor ID.
that one, yeah. Date, that's right. So we've got this one, and those ones. What else we have?
Purchase order ID.
Purchase order number, yes. PO number. PON, I guess. What else do we have?
Unit price?
The
Yes.
purchase order line, I guess.
Yes, line number?
Yeah.
What else do we have?
Item ID.
Sorry, item ID, yes? Description, yes? That's a lot of walking. What else we got? Quantity, yes? What else do we have?
Price and like.
Unit price. else?
Line total, I
Line total?
guess. This, what is it?
Total.
Line total and total.
Those last two must be killed.
Yes. Anything else? Nope. I think that's everything. So, good. Here's a second PO, purchase order. You can see that we have all of the same entities that we've already extracted. So, if we were to take all of these entities, line them up in a table, right? We get the following. Notice that this is another one of these things with all of these blank spaces. So, this is our unnormalized data. Multiple occurrences of the data exist. We can find cells that have more than one value, right? This cluster here. But these cells that have only one per purchase order, right, have blanks. So what do we do under first normal form?
Get rid of
We remove the calculated values and fill up the.
Right. We fill out the table and remove the calculated values. The calculated values are line total and total. We eliminate them. Good. Yes. First normal form has no repeated occurrences of data items in any cells. Precisely so. Very good. This is our result after having done that. Repeating values for attributes, all of those guys. Oop. Sorry. Do you mind if I take this? This is about my car.
Don't answer it.
Hello?
Yeah, that's actually, I like the theme.
That's Earthbound.
Yeah, there's one.
I thought it was like, I don't know, like some sort of Pokemon remix or something.
Earthbound.
Earthbound? Of course you
As
would
soon as
know.
I heard it, I was like, oh, Where do you think Undertale's up in France?
While you're doing the pointing, right?
Yeah, the guy literally started with the ROM hack, Halloween ROM hack for Earthbound. That's where one song came from Pennsylvania or whatever. And then eventually for Undertale, the creator started with the ROM hack.
Sorry. On Tuesday, I discovered my car had a flat tire.
I was playing a bit of what's up called again?
So what's the
I like
sound of the ringtone?
Oh.
Which
Could
sound?
be
Did you recognize it?
No, I didn't. That's why I'm asking.
Does anybody
Two
look like
of us did.
Earthbound.
Yeah. Earthbound? Yep.
Yeah.
The final fight.
Yeah.
Jesus.
Yeah. Where you fight Gygus. You are unaware of the. You are unable to comprehend the nature of Gygus' attack.
Is it like Undertale?
Okay, Undertale kind of started off as a fan game of Earthbound.
Yeah.
Yeah.
Oh.
It was like a
Yeah.
ROM hack and then
Technically, the developer.
Yeah.
making rooms
That's kind of crazy, actually.
Yeah.
for balance.
Yeah, the guy who made Undertale started off doing Earthbound ROM hacks. I just got to text my wife.
But it just became its own thing, I guess.
Yeah, I mean,
Kickstarter.
Earthbound is a cult classic. One second, sorry guys. Can you pick me up at 5:30, please? Yeah, there we go. God bless her. Where were we before we were so rudely interrupted? Oh yes, Earthbound is a great game. Let's see. His wife went to pick me up. I'm interrupting dinner, but yes, yeah. She's best. So, what was I saying? Yes, Earthbound's a great game. I highly recommend it. It's interesting, the sort of literary influences that went into Earthbound are a writer by the name of, what's his name? He wrote Slaughterhouse 5. Oh, it starts with a K. Oh man.
Kurt Vonnegut?
That's it! Kurt Vonnegut.
He's got some good sci-fi.
He's got some good sci-fi, but I wouldn't recommend getting into him because once you sort of scratch the surface level, he's such a doomer, that guy.
Yeah.
You know, if you want to read the most depressing book that you'll ever read in your life, read a book by him called Play Your Piano. It's basically a book about how automation is going to take over everything and destroy everything in the whole world.
Bit too realistic.
Yeah, it's a little too close to home, you know. Anyway, it's a very good game. Back to databases. Also, there's a whole area in the game that's based on Heart of Darkness by Joseph Conrad. But
Jesus.
yeah, yeah, it's even called The Deep Darkness. Anyway, I must talk about the boring thing. Click. Okay. So we are under first factor, what is it called? First normal form, yes. Under the first normal form, we end up at this table. What is the table's key? PO, well,
PO number repeats is the thing.
yes, PO number repeats,
It's gotta be another.
but it might be part of the
It's
solution.
gotta be another column.
Is
Right.
it a composite key?
Maybe line. PO number and line is the difference.
PO number and line would do it, yeah.
Or I.
PO, well,
It would be
Yeah.
nice, but I think line is a better one.
see, here's the thing, right? You could in theory have a purchase order if you include returns that returns 3 of a thing and then gets 20 of it.
Yeah, I think
Yeah.
line is a better one.
Yeah, so yeah, I think line number is probably a better one here. Let's see what the slides think. Boop. Ah, there we go. PO number plus line. So, second step. Isolating what data items are dependent on the parts of the key. What data items are left dependent on the whole. So, let's play what's dependent on what. So, we have eliminated from consideration line total and total. Those were eliminated under the first normal form. Let us see. We have PO number. We have line number. And we have both. Alright? So, let's get categorizing. So, date, what's that dependent on? Right. Date. Vendor, also PO number, yep. Vendor, good. Vendor ID, naturally. And vendor address, I think we can all agree, should all be clustered because they're all clustered, right? PO number, we don't, and line number are those. Item ID, is this dependent on purchase order, line number, or both?
I'd say line number.
How many people think line number? How many people think both? So, let's take a look at our data. So we're talking about item ID, right? So we have, is the item ID dependent on the line? It's kind of a bit of a, like, here it would appear to be, given this data. The thing that you always have to be cautious of during these types of exercises, at least in the real world, right? Is this data fully representative of all of the edge cases that would exist in a real system, right? I would say it is perhaps not true that your item ID, your item ID and description are, they may not be unique within a purchase order, right? It's possible that you may have a purchase order that contains them more than once, right? But they would always occur on different lines, right? So, a good way of determining this is like, if I hold this key constant, does the other thing get held constant? That's a test for dependency, right? So in this case, if we hold line number constant, item ID is constant. If we hold purchase order constant, item ID varies. So, I would say that item ID is dependent on the line number. Does that make logical sense to everyone? Okay. So, that's line number. Description appears to be entirely dependent on item ID, so they will get grouped together. Description, there we go. Quantity. Are we varying on line number, purchase order, or both? How many people think purchase order number? How many people think line number? How many people think both? Both hands. So here again is that test. If we hold line number constant, do we have varying quantities?
Yes.
We certainly do. If you'll notice, where line number is 1, we have both 20 and 80. So we are not completely dependent on the line number. We're dependent on something else too, right? If we hold purchase order constant, we end up with several quantities. So it can't be purchase order alone either, right? So this is the case where we need both. Does that make sense? All good? Yeah, yep. Hopefully there are no questions because I'm explaining this in a way that people are getting it. Yeah. So, that's quantity. Unit price. Unit price is entirely dependent on item ID and therefore will vary as item ID varies, right? So, unit price. So there we have it. Does this make sense? Shall we see how we did? Dependent on PO number, we have date, vendor ID. They're calling what we call vendor, they call name, and address. There we go. We got that one. In arrow notation, this is what it looks like. PO number gives us date, vendor ID, name, address, city, province, and postal code. Dependent on PO and line. Interesting. PO plus line, the slides are claiming quantity, item ID, description, and price. What we may have done is overstepped the second normal form and sort of been jumping immediately to third normal form, right? Or perhaps we would quibble with the slides.
We'll go back and see if
Yeah.
they really like what the slide said correct or not.
Yeah, so what they're saying is all of these should be dependent on both, right? Is item ID dependent on, actually now that I'm looking at it, so
Three spaces to 7.
does item ID hold constant when we have a constant line? So, I see. So in this case, both of these cases, item number 1 happens to be a P796. But for line 2, in one case we have 797 and the other 853. So, in fact, item ID does vary in a way that's not perfectly described by line number. So, the slides are right. The slides are right. Where's my chalk run? There we go. Item ID, and of course if item ID is there, we'll want to have these over there as well. So in the end, line number actually has no dependent properties that are only dependent on line number. So there's no table for line number, right? It would just be a table standing by itself. Okay, sounds good. Thank you, the slides. So, separating any entity that deserves its own relation in the database is the purpose of the third normal form. Another way of saying this, we are separating any properties, any attributes which are dependent on something other than the key. And we're making them their own table. Description, and it was unit cost. Boom. So, look at the key field that has a dependent attribute. A key for another entity. That's a confusing sentence. Is this occurring in our two second normal form tables? So, let's focus on this table, right? Do we have, so date. Is date dependent, what's date dependent on?
Nothing.
well, let's take a look at the, well, all of these are dependent on the purchase order number, right? The question is the date of the purchase order dependent on any of these other guys, right?
I would say vendor ID.
ID.
You can't have a date unless you
Vendor
have a
not
vendor ID,
existing.
unless you have a vendor making a purchase.
But if we have, like a vendor can make purchase orders on multiple dates, right? So the vendor ID does not uniquely determine the date, right? Unless they've only been entered into the system once, and that's not a reasonable constraint if you're a business, right? So date does not depend on the vendor ID, or vendor address. It depends solely on the purchase order. Now, how about vendor?
Vendor ID is dependent, or vendor is dependent on vendor ID?
Yes, there's, as we said, when we have perfectly dependent data like this, it kind of occurs in a cluster and we get to pick the one that we want to consider the primary key, right? Obviously, anything that's underscore ID is a good candidate for your primary key. So, vendor name, right? Vendor name and address both vary completely on vendor ID, right? So, we take this and we form its own table, right? With vendor ID as the primary key, and then name and address. I know address only has one D. Address. That now is a table. We remove this and replace it with vendor ID. I should probably turn the camera. Sorry guys. Let me just, yeah. There we go. Sorry about that, folks. There we go. Boy, this is a horrible room to try to do anything in. Yes.
Looking at this specific example, it looks like date is dependent on vendor ID as well.
Yes, it does look like data is dependent on vendor ID, but this is another one. You remember how I said, like, you have to be careful about data, right? You must doing this process is also requires just a little bit of common sense, right? If date were dependent completely on the vendor ID, that would mean that we would only have one date per vendor, right? Since we're running a business and we, in theory, want our vendors to, keep coming back, right? We want another company to make more than one purchase with us. Although this data would tend to lead us in the direction of believing that, this column is dependent on that one. In practice, it's not, right? If we had a few more purchase orders, if we had even one purchase order from like the same vendor twice, that would break this, right? And this is kind of like an artifact of the fact that this is a small example, right? Suitable for inclusion in lecture slides. Any other questions? That was a very good question. All right. So, let's consider this table. All right. Is quantity determined by item ID, description, or unit cost?
No.
Absolutely not. It is solely dependent on the primary key, the composite key for this table, right? In fact, let's just even say it. It's PO number and line number, just to make it explicit. What about description? What's that dependent on?
Item ID.
Item ID? What about unit cost? Item ID. So, we take these guys and we make them into its own table with item ID as the primary key. Very good.
What's gonna happen with quantity then?
Sorry?
What's gonna happen with quantity then?
Quantity actually remains in this table.
Okay.
Because it's dependent on only the composite key and nothing else, it's actually appropriate for it to stay right here. Not every piece of information is going to be broken out into subtables. Make sense? So, now, let's perform the further step. I've already kind of got these into, I'm starting to draw boxes around these. Dun 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 dun, you can probably guess where this is going.
You can do the relation there.
That's right. Oh boy, there you go, there's a table. There's a table. Here's one already, and here's one right here too. There we go. Now, when you're doing an entity relationship diagram, you label the primary keys PK. It does not stand for psychokinetic. PK, 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 chew.
What if we had a primary key called fire?
I mean,
Oh.
oh man, Smash Brothers references abound. So another little factoid about the Earthbound games. As part of your character creation, you get to pick like one thing that you really like or you love, and you get to pick a food you like, and that's what your mom makes you, and then you get to pick a thing you like, and that becomes like your best psychic powered move. The game Earthbound is about children with psychic powers who fight aliens. Anyway, so the next thing to do is to identify anywhere we have one of these primary keys used in another table. Ooh, I may have destroyed a little too much data though. Yes. So, is this one used anywhere else? Right there. So this one, as well as being a primary key, is also a foreign key. Very good. How about this one? Is this one used anywhere?
Yes.
Right here? FK? How about this one? Ooh. FK. We only have 6 minutes left in class. I will finish the remainder of the slides tomorrow. I'll record it and upload it for people who are, not gonna go. But I'm gonna finish this example. But there's a few more slides in here about transactions, which is important to cover. So we'll cover that tomorrow during the lab, during the opener. I'll record it and I'll upload that video for anybody who's finished the lab. You can watch it on the YouTube channel. I'll tack it to the end of this one. But yeah, I think it was important though to like do this in a bit more depth and like on the board. That's why it took more time. So, foreign key, there we go. Yes. So, let me just check with the slides, see how the slides are doing. Yes, so, let's see, we got vendor ID, yep, we got, yep, and yeah, good. I think we're doing okay, actually. So, the next thing to do is to draw the lines. So, anywhere you see a foreign key, that is the crowfoot's end. That is the many of the many to one, right? And the other side is the one. So, for item ID, this is the foreign key side. So you do the little crowfoot symbol, line down here, the one symbol, and there you go. Foreign key, that's the multiple to PO, there you go. If you want to be super fancy about it, you do it like so that it's not coming out of the bottom of the diagram, but like clicking into the line in the table so that it's like this. Like that. That's the fancy way of doing it. Foreign key, vendor ID, there's the primary key. It's also fancier to put all of your symbols on the same side of the table, if possible. There you go. Ta-da! By the way, on the slides, I put that here, so they're kind of like, yeah, but there you go. So, we took a couple of product orders, we have normalized the data and created an entity relationship diagram from those data. Any questions? Okay, and I'm going to cover transactions in the next 2 minutes. No, I'm kidding. Let me just see what the next slide says. Yeah, we'll pick it up from here tomorrow. Just so you know, there's a reason I hammered this. All right, learn, take it, and hack it into your brain meats. Okay. Have a good evening, everyone.
Sir, did you make changes to the PHP? Like,
Now recording. So, this is a continuation from the lecture that I didn't finish yesterday. Although if you're watching on the video, literally 0 time will have lapsed, so there you go. Explanation unnecessary. So, composite keys. Ooh. I know it's only the title, but I have to do my first digression. Alright? Apparently, that word is one of the words where you can tell the difference between a Canadian and an American. Because Canadians pronounce that composite, and Americans pronounce it composite. So there you go. If you want to ever tell the difference between an American and a Canadian, just have them pronounce that word. So, there are some database designers that do not like composite keys. So, you might understand why, right? In order to look something up by key, you're now having to look it up by 2 columns instead of 1. It's more work, right? More work for you, more work for the computer. An alternative is that any table that would have a composite key also gets its own unique key. The column that would have been part of the composite key just becomes a foreign key. This has emerged over the last few years, so by the time we are now speaking about this in 2025, this will be well-established practice, as the preferred design approach. So basically, if you have a composite key, you want to add an ID column, that actually has actual numbers in it to speed things up. There are two types of primary keys, natural and surrogate. Now, it kind of sounds like I'm talking about a different area of study entirely, doesn't it? A natural key is one that naturally occurs in the data, like the nursing unit ID in the community hospital database. A surrogate key does not naturally occur in the data and is usually a meaningless but unique number. You remember the M-buns? Well, they're back. So obviously anywhere you can use an M-bun, you can use the other one. So for example, in our PO lines, if you recall previously, this table has a composite key between PO number and line number. We now have a PO line ID that is the primary key for the table, and basically both columns of the composite key have been demoted to being just, at best foreign keys. Make sense? Very good. Putting that into the ERD, there you have it. The PO line table doesn't have a composite key anymore. PO line ID is a surrogate key, but still, you can, just because you've, slightly fabricated a series of numbers doesn't mean you can't use it for, very useful operations. In fact, all of the primary keys in this ERD are surrogates. So let's consider that for a moment. I'm not sure I agree with that statement. All of the primary keys in this ERD are surrogate. Some of them are M-buns, but it depends on what you consider, the place the data arises, right? If you consider the original, PO document, if you consider this to be your primary data source, a surrogate key is anything that you have to add that doesn't exist here, right? Which means that the only foreign key, or the only surrogate key is the one that we added for the PO lines. But, if you're considering, even if you're considering surrogate keys to be the same thing as M-buns, which is, to me, is a bit of a dubious claim, if we consider, PO number, that is a number, vendor ID, that is a number, but if we remember what item ID looked like, right? Our item IDs are actually strings. So, they contain numbers, but they're not strictly numbers. These, you might consider the item ID itself to be a compound attribute, because presumably the P indicates some kind of product category, and then the number that's after the dash is some kind of unique identifier within a product category. So that's actually a composite key. It's not, I think it's kind of a dubious claim to claim that that's not naturally occurring in the data set. I think that it very much is. But, so much for my quibbles. questions about primary keys, composite keys, yes, and surrogate keys? Any questions on those topics?
So surrogate keys are just basically temporary or
No, they're-
created, or?
They're not temporary, they're fabricated. So it's data that you add for database convenience that doesn't occur in the original data set. Yes.
Why don't they just call them natural keys?
There's a lot, like, I kind of feel like a lot of the terminology here was like put in place by like math majors, you know? I guess it's because, well, I don't know, like surrogate is a strange term to use, I agree, you know? Unfortunately, you know, you have to pick up the terminology because, like, this is like, of all of the programming areas, this is one of the oldest and most well-established, and it certainly has its own jargon, and part of the purpose of this course is to make you conversant in an interview, which means you need to know the jargon. So, and I know that's not a good answer, that's basically the because I told you to answer, right? But, you know, it's also true that you have to be conversant in this stuff. So, yeah, I if I had to design the whole thing from scratch, I perhaps wouldn't choose the term surrogate. I don't know, maybe back in the 60s when all of this was put together, the term surrogate and surrogacy did not have its current implications with, like, childbearing, you know? So, language moves, but sometimes jargon doesn't. So, we're now going to talk about transactions. All of the examples we have considered thus far have been geared to online transaction processing, or OLTP. You can tell how old this acronym is by the fact that both O and L of online appear in the acronym. There was a time before online was a compound word. Ha ha ha. So, when I say all the examples we've considered thus far, I don't just mean in this lecture, I mean in this whole friggin' course. Over the entirety of this course, we have been organizing our data towards online transaction processing. So, with online transaction processing, you want normalization because normalization promotes unique, that is to say, non-redundant data. Wow, I've never seen a more redundant instance of the word redundant, okay? Ah! So, due to all of the joining required to return meaningful results, normalized data is more complex to work with, right? The queries tend to be a bit more involved, right? Every time you have to join a table, you have to add like 3 lines to the SQL query, right? 2 or 3 lines. Derived columns cannot be indexed, therefore, normalized data can be slow to work with. It takes time to process all of this. For the sake of data integrity, in OLTP scenarios, there are trade-offs we are willing to accept. Although it's slower, it's generally presumed that the lack of anomalies is worth the extra processing time. If you recall, when I was talking, maybe it was last week, on the subject of these anomalies, like, normalizing the data isn't necessary to preserve the data, but if you're not normalizing the data, you're going to have to write some fairly complicated triggers and procedures to maintain your data integrity. The whole purpose of normalizing the data is that you don't have to write stored procedures and triggers to maintain your data integrity. The data maintains its own integrity because it's been minimized in terms of redundancy. So because there's in theory no redundant data, there's no redundant data to maintain, right? Among other things. So, however, online transaction processing is not the only use for data. Why would data be collected if it wasn't going to be analyzed as well? Online analytical processing, or OLAP, is one of the other significant database uses. Business intelligence tools, BI, not BO, BI, work with OLAP data to provide end users with the ability to analyze and report on the data in whatever way makes sense to the particular business. So, we're going to do a few slides and then I'm going to talk a little bit about machine learning. Okay? OLAP emphasizes speed and simplicity of access over data integrity. And doesn't that sound like the business case summarized, eh? In fact, OLAP databases are explicitly denormalized for this purpose. Data is also pre-summarized according to expected queries. So with OLAP, if you orient your database towards OLAP, you denormalize your data rather than normalize your data. You want everything out in one row, chunkily, in one huge table. That's what you want. Sometimes OLAP databases are known as data warehouses, and generally when people are talking about quote-unquote big data applications, there's a good chance that the database has been organized towards OLAP rather than towards transactions. And the reason for this is essentially that if you're going to be running analysis, automated analysis over the data, you're going to be doing a large number of transactions, and you need to have the database optimized towards the speed of transactions rather than towards maintaining the integrity of the data. So, data in an OLAP database is often conceptualized around the concept of a cube, where one of the dimensions is time. So if you imagine you have rectangular data, right? You have a spreadsheet. If you model changes in that data over time as like the other dimension, you suddenly have a data cube, right? Business information tools allow slicing, dicing, drilling down, etc., all of which are technical terms. Slicing would be a technical term. I doubt that dicing is a technical term. Consider the following chart. GDP in billions of various regions in the world. Wow. Is it really doing like gold, silver, and bronze for GDPs? That seems to be what it's doing, eh? And then blue. I think there might be like a little bit of implicit bias in this chart. Also, GDP is an awful measurement. Don't use it for any measurement. In a business analysis tool, you would be able to click any element to drill down to see more data in detail. The following slides will present a simulation. So, if we click on the Americas, so you click on any of these bars down here, you are presented with a distinction between North and South America. South America, North America. Presuming you click on North America, whoop, you are now presented with all of the countries constituting North America. It's interesting actually where they draw the line, eh? Because like, I don't know about you, but you kind of get the impression that like North America is just Canada, the United States, and Mexico. But like they're including a lot of like Caribbean countries in this as well, which like I guess is true. It's just, you know, it's kind of interesting.
They're basically lumping Central America.
Yeah, I thought Mexico was Central America.
No.
Yeah, it's
So
like-
Mexico's north.
Oh, it is?
Yeah.
Oh.
Yeah,
Cut off is Panama, so.
Yeah. yeah, it's like, yeah, it's, you know, if, I suppose like most of the time we think of it as like a threefold rather than just two, like north and south, even though that's kind of how the continents work.
Mm-hmm.
But yeah, anyway, if you click on Canada, boop, you know, Canada, the country that all the rest of the countries are sitting on in this graph. You get a view of GDP broken down according to region in Canada, which again is like, you know, first of all, GDP is an awful measurement. You guys know why GDP is an awful measurement?
Yep.
Tell me why.
It gets added anytime a transaction happens.
Yes.
So like I remember the joke, like one millionaire tells this poor guy, you eat that turd on the floor for $1 million.
Yeah.
He does it, gets $1 million, and then now the guy says, oh, I'll give you back $1 million if you eat this other turd. It's like, he does it. Great,
Yeah.
we've added $2 million to the GDP, but we've both eaten turds.
Yeah. Another thing about it is that like government spending ends up included in the GDP, even when the government is going into debt to perform that government spending. So like, it's like, you know, if it's very important to government officials that the GDP continues to increase. You know, it's very important that line go up. So the easiest way, rather than like actually improve the economy, the easiest way for a government to improve the GDP is to just go further into debt, which is probably like indicates a fundamental flaw with using GDP as your metric for how good
Just
your
move
country
money
is.
from bank account 1 to bank account 2 and then back.
Yeah.
Or then put it in that circular PHP loop.
Yeah, you just have, you know, just invent a bunch of fictitious transactions and suddenly, you know, there you go. And as long as the government can tax it every time you do that, you know, they're happy. But yeah, anyway, so this doesn't necessarily mean that Ontario is the best province in terms of its economy. It just means that it's in the most debt, perhaps, which is probably closer to the truth. So, Gapminder is a Swedish nonprofit venture, at least it used to be. It promotes sustainable global development. It provides an excellent BI tool to analyze a number of statistics. Let's see if the link still works. It does! Yay! GDP per capita. Yes. Again, GDP is awful. Yeah, I don't know. If I look at statistics, I'm probably just going to get angry, so. It turns out I'm the kind of guy who gets angry at numbers, so. There's something that, like, probably should be talked about. So would you guys like a very rough introduction to how machine learning works? So,
Tokens.
hey,
I said tokens.
tokens. Well, Yeah, so I'm gonna be talking about like clustering analysis, right? So basically, like, nobody really knows how LLMs work, right? Some kind of like neural network or something or other. But like there are actual analytical methods that you can use to derive machine learning models that do not require training a neural net, right? You can get a certain degree, you can get, a certain degree into it just with statistical analysis, right? So basically, if you have a like fairly large data set, right? Something like this. Imagine you have like 10,000 entries, right? How it essentially works is you take each of these values, you convert them to numbers in some manner, like they are all numbers anyways, even the strings. You then consider that an n-dimensional vector, where each one of these is one of the dimensions of the vector, right? So, this is a lot of dimensions. We're past the point where like we can visualize 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dimensional space. That's more dimensions than string theory even claims exist, right? But once you've made it a vector, you can start doing things like calculating the distance between different point positions in space, right? So, basically how it works, I'll do this in 2 dimensions because that's the dimensionality of my board, right? But essentially, once you do this, you'll end up with, something that looks like that, right? A bunch of points plotted in n-dimensional space, right? You then calculate the distance from, one of these points to all of the rest of the points, right? And if that distance is under a certain threshold, you consider that a cluster, right? So you've got a cluster over here, maybe these count as clusters, and then these are outliers, right? And so the assumption that machine learning will often make is that incoming data can be categorized according to the existing clusters in the training data, right? This would be called training data if you're doing this kind of analysis on it, right? So basically, for any incoming data, if you have a new piece of data that falls right there, you can see that this piece of data falls inside of that cluster. And the question is like, what is the cluster, right? And that's kind of like, that's the somewhat more difficult mapping. If this were something like image processing is like one of the classical things they teach you in machine learning because it's like very, very visual and you can kind of get what's going on, right? Like under classical like image processing machine learning, all of these points may correspond to pictures of a cat. All of these might be corresponding to a picture of a dog, right? This might be a hamster. Hamsters are more similar to cats than dogs, that sort of thing, right? And the way that you arrive at these categories is that the training data needs to be labeled itself, right? So, like if each one of these points comes with the label cat, right, then we can presume that all of the points, if most of the points in here have the label cat, that's like the cat cluster, right? So if something else falls in that cluster, it's a cat, according to the machine learning algorithm. Of course, this isn't a perfect process. You might have like a strange cat over here who doesn't fit the general, clustering, right? And of course, things can look like cats without being cats, right? Perhaps this is like a picture of a child dressed as a cat or something, but it looks enough like a cat to fall into this category, right? But you can kind of if you're doing this type of analysis on the data, hopefully you can see how you want everything in one table, right? You don't want the data split up amongst a whole large number of tables where you have to do some complicated joins to even get one record out, because we want to consider the data as a vector. Like each record is one vector in n-dimensional space that we're doing clustering analysis on in this fashion, right? You want this to be a big table of vectors, not spread out amongst a whole bunch of different tables, right? It just natively works with that type of analysis much better. Does that make sense? Cool. Did you learn something about machine learning? Maybe I should show that board for the poor viewers at home. There's my graph. Isn't it pretty? There we go. All right.
So then what happens if you give it like a picture of half a dog and half a cat? Breaks.
Well, it depends on how many pictures of half a dog and half a cat it gives, right? Like, if your data set, if your training set is composed entirely of cat dogs, right? Then you will have trained the data to recognize cat dogs. You'll train the system to recognize cat dogs. Therefore, would it categorize a cat or a dog as a cat dog? I guess it depends on which half of it is more distinctive, right? Unless you're actually talking about the actual literal 90s cartoon cat dog where there's a cat face on one end and a dog face on the other end. In which case you have the most distinctive feature of the animal on both ends of the animal, right? You'd end up with an anomalous category.
So it'd be like an outlier.
Well, if you had one, yeah. Yeah, if you snuck a picture of a cat dog, it would not cluster. Hopefully it wouldn't cluster up with any of this data. And we're talking about, you guys know linear regression, regression analysis, where you do a trend line in data. It's kind of a similar concept to that, except it's n-dimensional regression around a cluster rather than doing a line, right? It's a similar sort of statistical analysis. Basically, during this sort of regression analysis, you're trying to find the center point of a group of data under a threshold distance. And so we come inevitably to the point in the lecture where I bash large language models, right? So this is kind of the classical machine learning approach. A lot of machine learning boils down to categorization engines of this nature, right? Basically, this is the proposition of AI enthusiasts. And I personally think that the AI enthusiasts have had a rough year. But you know, there are some people, like, it doesn't matter how rough a year they're having, if they're true believers, then, you know, there's no amount of evidence to the contrary that's gonna dissuade them. But, like, basically, here's the question, right? This is the question that, like, the chatbot becoming the singularity comes down to. By the way, do you guys know, like, what the singularity is? Like, how they define it?
Is it that they become sufficiently complex to have like self-awareness, or?
Not quite. Like, there's a more technical definition of it. The technical definition of the singularity is the point at which the software becomes capable of improving itself, right? So the idea is that you'll have like a version that's like this good, right? And it's now capable of self-improvement. Say it takes, you know, 3 weeks to generate its next better version, right? So it takes 3 weeks, but it improves itself. The improved version of itself should be able to improve itself faster than the previous version. So maybe it only takes 2 weeks to reach this height. Well, the improved version should be able to improve itself faster. So it makes its next version in half that time, or, you know, a reduced amount of time again, right? And so the idea is that it should be able to cluster its own improvements at narrower and narrower spacing, and essentially the graph of its improvement looks exponential. This is what they talk about. This is what they mean when they talk about the exponential improvement of AI, right? But the problem with all of these people who assume we're in the exponential growth of AI phase is that we're not. Like, the AI is not capable of improving itself, right? ChatGPT has not, ChatGPT 4 is not writing ChatGPT 5, right? It's probably helping, but like, it's not reducing the time to versions, right? In fact, basically everywhere people have become overly reliant on the AI to write stuff, things are breaking badly, which is why I say that the people who expected this are having a rough year, right? So basically, the theory for how this comes about is that if we just throw enough data into it, right? If we just throw enough data into it, it'll be capable of doing this, right? But this is not true because basically the AI has at this point consumed all of the quality data that exists. So what data are they now using to try to improve the model?
AI-generated data?
That's right, fabricated data. So now the thing is only amplifying its own errors, right? And you may have noticed that like a lot of stuff is like information quality in general is degrading rapidly at the moment. Like general information quality on the internet is like, it's degrading. Tutorials that were helpful like a year ago, the sorts of tutorials that were helpful a year ago, the same, like they aren't anymore, you know, a lot of them. This is my experience at least. Anytime you want actual answers, you need to be checking Stack Overflow itself, right? But yeah, so basically what it all boils down to in like classical machine learning terms, if I have a machine learning algorithm and I'm giving it pictures of dogs and cats, right? If I give it enough pictures of dogs and cats, will it be able to recognize an elephant?
No.
Probably not, right? Because it doesn't have that category in its training data, right? Even, like, it's impressive the amount of data that they've fed into the LLMs, but they're still not capable of doing anything that wasn't fed to them, right? So forward technological progress, right? So they can't do this. But anyway, question.
I'd be very curious to see if you could ask an AI to write a programming language and see what language it gives you.
I mean, some of the early early attempts at like playing with AI. Simon Galton has been on this train for a while. One of his early attempts was to get it to invent a programming language called TrekScript, where like all of the variable names are required to be like names of actors who played roles in Star Trek, and that all of your classes are required to be names of episodes from like the first Star Trek. And like, it'll do it, but it basically comes out as like Java or some, I think it was kind of Java-esque, or maybe JavaScript-y, and like just making horrible syntax errors all over the place and stuff. Yeah, like asking, here's the other thing about that, right? Asking it to write a couple of examples of a fictitious language is one thing. Asking it to write a compiler, that's an entirely different thing, right? And I say this as a person who did his PhD writing a compiler. It took me 10 years and it wasn't very good, so. Anyway, data warehouses. Offloading data from the transaction-based database to the OLAP database allows each database to be optimized for its particular task. So basically the answer to the question is, well, what if I want the best of both worlds? The answer is, keep two databases. This separation ensures that complex, heavy inquiries in the OLAP database don't cause slowdowns in the production database. And like, you offload data into the data warehouse every, nightly or however often you want to do it, right? Summary. Normalizing data into the third normal form is almost always adequate for real-world processing. OLAPs denormalize and summarize data for quick and easy analysis. So, any questions?
So, when they say the production database, that is the transaction one that we have normalized.
That would be the one that like your POS system is interacting with. Point of sale system.
And
Yeah.
then, what method are we using to send the data over? Is it like triggers set up in the production database to like, okay,
Yeah,
let's like create or update the other database column?
if I were doing it, I absolutely would have the data warehouse and the production database as distinct entities, right? They would be both their own databases, absolutely. Yeah, I'm sure somewhere there's some way of, like there's probably some TSQL statement somewhere that allows you to fire off an SQL packet to another database. That must occur. In fact, I bet we could look it up.
So basically, instead of creating a view using the one, they just figured that it's better to build a separate unnormalized table just to do the line-by-line processing, I guess.
Not even a separate unnormalized table, but an entire, like, its own physical hardware. And the only purpose of it is to contain the unnormalized versions of the production database.
So for this second optimized for like business, is it really like that new database, is it just gonna be one table then of like everything that was required?
Sorry, can you repeat the question?
Okay, so when we're like creating the unnormalized second database from like
Yeah.
pulling all that, is that just gonna be like a single table then?
Yeah, or close to.
That's how my company does it. We
Oh.
have a system, yeah, so we actually have a BI system that
our main data, there's a copy of it for a read-only database. Our BI system pulls that in, table by table, and then creates data sets, which is just joining all those tables to make one giant table to use for BI.
Yeah, and that's like a separate system, right?
Yes.
Yeah, so there you go.
It's literally just a copy of the main database that it works with, so you pull out that data.
Mhm. You should be talking about this. Yeah, so in the case of the system you work with, it's the data warehouse itself that is performing the queries on the production database.
The production database has a copy that it writes to, I think whenever data is put into the production database, it's also putting it into a read-only database.
Ah, yeah, okay, yeah, that
And
makes sense.
then the BI system takes that and makes it has its own separate database that it works with to make the normalized data.
Yeah, see, that was an approach that I considered while I was doing this. It's like one way that you could easily maintain both is you write a middleware layer that anytime you receive you receive data from for example, a point of sale system, it just, it fires two queries instead of one to the production database and the other to the data warehouse, primary and secondary. Very good. Any questions? Very good. All right, I guess from this point forward, we're finishing off Lab 7. Thank you very much, everybody, for coming this morning. And the video will be posted for the benefit of the rest of the class at some point, hopefully today.